Good day, my name is Peter Lucas. I will be giving you a demonstration on Introduction to Resistors. This will cover TAEDEL301A, Demonstration B. The Introduction to Resistors. The first thing that we need to discuss is what is the function. What is the resistor's function? The main function for resistors are to impede the flow of electric current. This basically means, in layman's terms, that we need to restrain the flow of electric flow. So when current flows through a circuit, we use a resistor to stop it from going faster. The second thing that we need to know, where do we find them? We find them in electrical circuits, we find them in electronic circuits, and basically anything with a television, a radio, will have a resistor inside. You will find different sizes of resistors, 1 watt, 5 watts, 10 watt resistors, and with multiple resistor values, from 0.1 ohm to 50 mega ohm. You will also find resistors in appliances. What type of appliances? The type of appliance I'm talking about is a heater element, which is your normal heater, electric heater. We talk about your hot water cylinder. There is a heating element in there. That's also a resistor. It's just a very high watt resistor. So when we look at these two parts, we can say, what is the function of the resistor? Resistor is definitely there to impede the flow of electric current or to slow down the electric current, but it also, with that, comes a heating part to the resistor. So by stopping the flow of electric current or slowing it down, it actually gets warmer and you can get hot water. You can get a heating element that heats you up. So that's a secondary function of the resistor. The third thing that we will be discussing is formulas. In resistor networks, we have two types of networks. One is a series network and one is a parallel network. And the last one is, how do we calculate them when we have a little resistor in our hand? So if we have a resistor in our hand, there is a certain formula that we need to follow to actually achieve that. So let's start with the following. So we know what is the function, we know where to find them, and now we need to know how to calculate them. So let's get onto it and start looking at the formulas. So in a series resistor network, so this is your series resistor network, there is a formula. The formula is RT, which is total resistance, equals R1 plus R2 plus R3. And if you do have any more in series, then you will just add them together. So let's look at the resistance. So total resistance means we have to take all three of them and add them together. So let's look at RT equals R1 plus R2 plus R3. In this circuit, we have three resistors in series. If there was more, we just have to add them on. So let's put some values to it. First resistance value is 6. Second value is 12 ohms. And the third value is 3 ohms. Ohms is the unit of resistance. So let's see, what do we get at the end of it. 6 plus 12 gives you 18. 18 plus 3 gives you 21. So that is 21 ohms is the total resistance. The value of a resistor can be written as 21R, which is acceptable, or 21 ohm, and that is the omega sign. Now that we've got total resistance in the circuit, and we know we've got total voltage, we can work out total current. So what is the formula for this? For this function, we need to use Ohm's law. And if we just look quickly to Ohm's law, there's Ohm's law. So we've got the triangle. Let me explain this to you. On top we have V, which represents volts. At the bottom we have I, which is current. And on the other side we have resistance. So if we want to find out what is the voltage, we multiply the current with the resistor. If we want to find out what is the current, we divide voltage over resistance. The same goes if we want to find out what is the resistance. We need to voltage over current. So it's very, very easy, and let's apply to the circuit over here. So in this circuit we have total resistance, we've got total voltage, and we can find out the total current. So we say I total equals, and the formula says V volts over resistance. Let's have a look. What is the volts? The volts is 12 volts. The resistance is 21 ohms. And if we use a calculator, it doesn't have to be a very fancy one, like a scientific one. You can just use a normal one. And let's do the following. We take 12, divide by 21. That gives us a total current of 0,571. So that's 0.571 amps, or it can be written as 571 milliamps. Okay, so now let's go over to parallel electrical circuits. Parallel electrical circuits, you will see we're going to use the same amount of voltage. We're going to have a little switch. The only change that we're going to have is where on a series circuit you have the resistors side by side. Now we're going to have a difference. We're going to have the three resistors on top of each other. As you can see, they are R1, R2 and R3. They are the same values as before. R1 is 6, R2 is 12 and R3 is 3 ohms. When the current goes into the circuit, or the voltage goes into the circuit, it enters with 12 volts. When it comes out on the other side, depending on the resistor value, there will be a volt drop across the resistor. The resistor will absorb some of the resistance. A 3 ohm resistor will have much less resistance, and the voltage drop will be lower compared to a higher value resistor. If we draw a simple little circuit here, let's say voltage and resistor. Lower voltage, lower resistance, a higher voltage. Let's say R12, let's put them on a scale here. So that's 12, that's 6 and that's 3. 3 will have a lower volt drop than 12. What does that tell you? Resistors are linear. But let's get back to the resistor network and just quickly do a calculation for you. So the formula for a parallel network is 1 over RT equals 1 over 1 RT plus 1 over RT2 plus 1 over RT3. That is the simple little formula. So let's first write it out. So here we go. So that's your formula. So let's put some numbers in there. RT1 is 6, RT2 is 12, RT3 is 3. Once again, I'll make use of my calculator. Let's use 3 numbers. Okay, so let's add those up. Let's add all of those together and see what is the result. 0.166, which is RT1, plus 0.833, which is RT2, plus 0.333. If we take 0.166 plus 0.0833 plus 0.333, we end up with a number of 1.332. Divide by 1 gives you 0.750. Let's just make double sure of that one. Plus 0.833 plus 0.333, 1.332, and we divide that by 1, gives you 7.50. Okay, that gives us total resistance for this circuit.